Hello there, today we're doing infix to postfix. So earlier we did a postfix to infix, and now we're doing an infix to postfix. An example of infix to postfix is how we naturally see a mathematical problem. So here we have a plus b times c plus d, and as you can see here, b times c takes precedence before we add a, and then after all that we can add d afterwards. So this is how it would output in postfix format. And also in input here, we have parentheses. So what happens when we have parentheses is that we have to deal with the parentheses first and add this particular item first whenever we add all the operators first when we see a parentheses. Now, of course, now that we've seen two examples, we can think of some problems already. So the first problem that we can think about is an edge case. So what if, like, we have an input where we have an open parentheses first, closing parentheses without any opening parentheses. And let's say we have a bunch of operators without any operands, right? Wouldn't that be a problem? Well, yes, it is going to be a problem in the sense that this is an improper input. We can't, this output, what we should expect here is a -1 or something, right? Something that just can't be had. It's impossible. We can't work with this. We can deal with this by saying, oh, if we do not find an opening parentheses, then it's not a problem. But there's another edge case now. The other edge case is that there is an open parentheses and there is a closing parentheses. However, what do you think this should output? Should it output a should it output all of these symbols into our string? Is that what we want to output? I don't think so. But we don't have any way of handling that at this point. However, can we think of a way to deal with that? Can we think of a way to see how many operands were available at that particular time? So let's suppose this was the case, and we would need 1, 2, 3, 4 items, 4 characters prior to these 3 operands for this to make any sense whatsoever. So if suppose we see that, then we can have A, B, C, D, right? Of course, this division comes before the subtraction and the addition. So how would that work? Do we want to handle that in this particular problem? And if we do, how do we handle that? Like, do we count the number of operands that are available? Like, count these items, and as we remove these operators, we subtract the total number of operands that are available. And how many do we subtract? So we have 4, right? And so we have 4 operands, but we have 3 operators. So do we subtract 3 operators? And do we have 4 operands? And how does that work? How about we have number of operators? We do a operand -1. How's that? That will work, right? That way we can subtract away one of the operands. It's kind of dark, I think. Give me a moment. Okay, it's a bit brighter now. Let's get to it. So we solved a couple edge cases. Can we think of any more edge cases? Because edge cases are very important for us to make a functional program to see exactly what we want to operate on. Another thing is we don't have to handle this case. It's not like the interviewer can say, oh, we don't need to handle the case where we have improper inputs in the number of operands to operators. That will make the problem much easier for us. And let's not handle that. Not handled. This is like a bonus question. Bonus. So we don't need to solve it. We'll just solve it later, right? If we have extra time. And it's not that much harder to solve after we solve the initial problem. But we do have to note that this is an edge case and we want to solve it if necessary. And we've noticed it. So, are there any other edge cases that we should handle? How about like all of these? How about just A, B, C, D? And there are no operators. Like the output would be A, B, C, D, but what the heck does that mean? Nothing happens to these variables, right? And so we're gonna have another problem. So that is also not handled. Bonus. So that's another issue that can be handled if we knew the number of operands, and at the end we have a large amount of operands, then let's not deal with it. Okay, but we have bigger fish to fry, and that fish is how do we solve this initially and this particular, the happy case. Because those are important. That's the meat of our algorithm. And so let's lay off the bonuses for now, and let's think about how to deal with the bonus problems. Let's think about how to deal with the happy case problems. So after this much understanding is that I have a hypothesis. The hypothesis is that we have to look at every single character. So it's going to be O of n for looking at every character. Now, the space, yeah, it's about O of n as well for every character. Okay, so let's handle this. So how do we deal with empty spaces? Let's think about that first, right? So match. Let's match a pattern. And the pattern is going to be a loop. Let's just do a loop. And we do need a stack. We'll need a stack because we notice that these items, we can insert these operands first, and then we can deal with the operators. The operators seems to operate like this. The bigger, the items that have precedence go first, and the items with less precedence goes after that. So if at any time we add items to a stack, and we have any item that is equal or greater than our previous item, or greater than our previous item, then we can add that to use those operands on those operators on our operands. So in essence, let's say we have A, and then we see plus sign, right? So we have a stack. We have a plus sign to our stack. Now we have AB, and we have a multiplication. Multiplication is here. So we have multiplication, and that multiplication is not, if we append that now, then we'll be missing the C. Let's add that C in, and then see the next character. So next character is an additional sign. So additional sign, is that less than or equal to our previous item? Does it have less precedence? If it does have less precedence, that means we need to use up our operands now. So that way, we use up our operands, the multiplication, and the plus, and then add the new plus back into our stack. That way, when we add the last item, D, we still have something in the stack, so we at the end of our loop, we can add this last addition sign back into our string, and we have completed our output. Okay, so that is our first plan. Plan is go through each char in string. If it is operand, add to string, add to output. Else if it is an operator, add to stack. If operator has lesser precedence than previous item in stack, then add all items in stack to string. Then add to stack. Then add operator to stack. So that's exactly what we have done. And at the end of the loop, add remaining items, so operators, from stack to string outputs. So with that, we are able to solve this case here. However, we are still unable to solve the parentheses case. In this case, what we need to do is handle the parentheses. So let's check it out. So first things first, a parentheses is an operator, so we add that to our operator stack. Now we have another open parentheses, so that's our second item into our stack. Now we have an A, so we have an A, and now we have an additional sign. Suppose we have an additional sign, well, we're going to check that precedence. So in our dictionary, let's say we have a dictionary precedence, and we're not dealing with precedence between an additional sign and then parentheses, so let's just ignore that. Okay, so if it's not in our dictionary, let's ignore it. So handle parentheses. So only operate on with closed parentheses. So we don't do operate on it, and we keep going. So we have a B now, right? We have A and B, and we have a closed parentheses. So we have a closed parentheses. So what we're going to do now is use up all our values until we see a open parentheses. So we use it up, we take it away, and we pop that off. And now we're done with AB plus, as you can see quickly, right? So now we have a subtraction sign. Let's subtract, right? And we don't handle the closed parentheses until the end, until we add the F. So should we continue going through all of this? Maybe we could. So let's add the C in, and let's have the multiplication sign. Does that have higher precedence? Yes, it does not have anything lower or equal to precedence, so we don't have to deal with it yet. Now we have an open parentheses. We add that into our stack, and we take add the D in, and we have a closed division. So we don't have anything to deal with that. It does not check against the parentheses, and we put the E in, and then we look at a closed parentheses now. A closed parentheses, that means we have to add all the operands in, and then we finish off this closing parentheses. Next, what we see here is a closing parentheses again. So that means we have to use up all the operands here, the multiplications and the subtraction afterwards. And with that, we are done with all our parentheses, and now we have an addition to our stack, and we have an F. And lastly, when our stack is done, we use up the last of our stack, and we get the particular output that we wanted, as seen here. This is an equal output. So that means that the plan works out pretty well, and we have reviewed the code in terms of our plan, and we can implement it now. So let's implement it, and let's implement it up here, if that's a good idea. As you can see, we're in 15 minutes, so this is going to be a pretty long video. So let's take a string, and let's say the string is this, right? We're just going to handle happy cases here, and maybe handle one of the edge cases, because we are limited on time, and I don't want this video to go on for too long. So let's just handle a few of these things. Let's see what we can get to after the happy case, and we're making sure that this video doesn't end up to be more than 30 minutes. Let's just go with that as our deadline, and because there are deadlines in interviews, and we can't just make it past our deadlines, right? That's not no good during interview. So let's just remove all the items. So s dot remove. So remove all the empty spaces and set it with closed spaces. And that should return, and if we turn s now, we should be able to see that we have reduced all the white space. Looks like we don't have that, and I'm not sure exactly how to remove all white space. Let's check that out. Remove white space, Python. Okay, let's check it out. So it looks like it's replace. So we use replace. Let's run it. Make sure that we're going in the right direction, and we are. Great. So now we can do every single character in string, and if character is alpha, that means it's an operand, and that means we're able to say output dot plus equals our character. So we do need an output that is equal to an empty string, and we do need a stack to hold our operators. So the problem here was that we don't see our plan, and because we don't see our plan, it makes we forget things, and we don't want to forget things. So I'm going to move the plan up here so that I can look at my plan and see what we're trying to do. So go through every character, if operand, add to output. Okay, otherwise else add operator to stack. So we have a stack here, and we can now add it to a stack, right? So let's add it to the stack. So stack dot append, C, right? And we need to, if operator has less precedence than the item in the stack, then we will need to remove all of these items. So we'll add the stack at the end. So if or while stack and the previous item. So there's an item in the stack, and the previous item, its precedence. So we don't have precedence at this point. Precedence is equal to, let's set the plus sign to be 1. Let's set the minus sign to be 1. Let's set multiplication sign to be 2. Let's set the division sign to be 2. Let's set the exponent, the exponent sign to be 3. That has third priority, and that's it. So if precedence of this character is lower or equal to the precedence of our stack at the previous character, then we can append it. Then output dot append or dot plus equals our stack.pop. Okay, so with that, we have inserted all our items, and with this, we're able to solve this first part. We're not capable of solving the second part yet, but we are able to solve the first part. So let's return the output, and we should expect to the correct solution, as we can see here. I don't think that's actually right, because we are missing something, and that something is to empty out our stack. So while stack, we're going to output plus equals stack.pop near the end. So let's add it. What happened here? So, I see. We did not run the function. My bad. Okay, so we got the solution, and it looks as expected to our output, our happy case, as you can see here. So we're ready to finish up our second part. So our second part is to deal with the parentheses. So if it's equal to open parentheses, then let's add it into our stack.append C. This also means that close parentheses. So this also means that we can't deal with this, because if we see this in our precedence, that means that it's we can't compute that. So if C in precedence, then we can deal with it. If not, then we don't deal with it. Okay. So next. So what happens is that while stack and this item, so stack at the next item does not equal to a opening parentheses, we're going to keep popping all the items and adding it to the output. Right? So if not stack, that means we've run out of items and we still haven't seen it. We can return -1. That means we have a bad out input. Otherwise, we can run stack.pop, because we have found this item, this closing parentheses. So stack.pop the closing parentheses, and we're good to go. And we are able to have solved this next part of the problem. Let's check it out. We still have an issue with this key error, which was not supposed to happen. So while stack and C in precedence, and C is less than the stack. So it's stack at -1 in precedence. So with that, we have solved that part of the problem, and we have gotten our happy case to work out. We also have gotten our edge case to work out as well at this point. We're currently at 22 minutes, so we might want to end this early, but let's end this early. And so we do have a -1. This is perfect. We handled one of our edge cases, and we still have a couple more edge cases where we have the wrong operands and the wrong outputs. So how we deal with that is that we do a count of, let's do a count. Maybe it works, maybe it doesn't. Count operands equals 0, right? And so what happens here is that count operands plus equals 1. Okay, so every time we see an operand, we plus equals 1. Okay, so next thing we do is that when we see a point in time where we are, using operators, let's add an operator. So every time we add an operator, we do operator count operator plus equals 1. Yeah, So do we do plus equals 1 for these? No, those are separate. Those we don't deal with. Okay. So now we need to subtract these items at this point. So as you can see, this is the point when we lose operators. So count operators minus equals 1, and we have a count operand minus equals 1. Okay, so one thing we do need to do first is that we need to make sure to add we can add an operator or subtract an operand, but I think the best way to do this is to say if like any of these go into the negative, then we are in trouble. Yeah, or if any of these, if the count operator goes below 0 or the operands go below 1, then we have a problem, right? So what's happening here is that we don't have count operator. Count operator is equal to, let's say 1. Yeah, that's the way to do it. So with that way they are always, once they both hit 0, then we're good to go, right? And it always has one bonus item that it always starts with, right? Is that how it works? Or, I mean, once they both go down to 0, I don't think this will be able to run again. So I don't know exactly the dynamics of this, but I'm just going to go with the way I feel like it will work. But I think there's always a more efficient way and more clear way to do this. And so with that, if count operator is less than 1 or count operand is less than 0, we can return -1. That's handling the edge case. And we do the same here when we do this pop action as well. So we have to remove the operator and operand, and we're good to go. And that's it. That's all. That's all the additional code we needed to solve our edge cases. And let's solve one of the edge cases. Let's check it out. So let's try. So our string was, one of our edge cases was this input, and this should return a -1, I believe. And I broke the code. Okay, looks like this is a little bit more difficult than I thought. So count operator less than 1 and count operands less than 0. I'm not exactly sure what the debug process is, but we will have to debug it later. Because we are hitting up our 30-minute mark, we were not able to solve the edge cases, but that's fine. We're able to solve most of this problem, and I'm really glad that we got this far. So that shows off a lot of your problem-solving skills, and we have gone very far with this problem and solved how to move from infix to prefix, which is a very difficult task. And we were able to do it within a 30-minute time frame. So with that, I hope you learned something today about solving coding for a coding interview. And if you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one. Of course, give me a couple more seconds, and I think this is called review, and the evaluation for this problem was that it was exactly evaluate is going to be O of n before every character, and we're gonna generate a string that is O of n space as well. For char in S, and for a string of equal length to S. Okay, with that, I'll see you in the next one. Bye.